Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Jamal Ishwal bin Ambut Miri, and today throughout this video, me and my another two team members, which is Amirul Imran bin Makno and Muhammad Amirul Hafiz bin Muhammad Aminuddin, we will be presenting for our final project for the subject of BTM3514 Computer Integrated Manufacturing. So basically here we have been assigned with three questions, question 1, 2 and 3. However, I will only explaining for the question number 1 and question number 2 for the calculation part. So here, basically on the question number 1, we asked to create or calculate on creating one unit load ASRS for working in process to storaging in a factory where all the value of our ASRS system must meet the requirement as stated in this table. The total capacity must at least able to store 1000 pallet, not including the allowance of 20%, and then it must be two isles, and then the pallet dimension XYZ respectively 360 millimeters, 480 millimeters and 480 millimeters. In terms of the tolerance of the pellets, the value we inserted by ourselves, and then the height from the floor must lower than 50 meters, where the space between the rack and the ceiling at least 20 centimeters. So based on this value, we have calculate important thing that will be used later on our simulation for the ASRS system on the analogic simulations. So in terms of the total storage capacity here, including the 20% of allowance, it at least must be storaging around 1200 pallets. And then since we got two isles, so around 4 row of storaging system, so one row must allocated 300 pallets. And then the actual height, including the calculation from the allowance value ABC previously, so the actual height at least must be 14.3 meters, the actual length around 10.2 meters, and the actual width around 3.06 meters. So all this value will be used for the setup on the properties of our ASRS system on the simulation later. So we go on the question number 2. So basically on the question number 2, we got question A, B and C. So for the question A, it stated that we need to create one value for ASRS system that at least later it will go through a rate of 13 SR transaction per hour for the period of our peak activity, which is for the part of our CNC1 transferring to our CNC2, the process between CNC1 until CNC2. So here we find the value of TCS, TCD, RCS, and then 2RT, and finalize we got the value of our RT, which is 21.03 transaction hour. So if we compare between our calculation and the value that stated by the question, at least 13 SR transaction per hour, so actually our value or our calculation actually are valid, and it's already meet and satisfy the questions, since we got 21.03 SR transaction per hour comparing to the requirement that at least 13 SR transaction per hour. So if we go through the question B, when we compare the value by using the calculation of utilization, here we can get the value of 61.82%. Therefore, the utilization value ASRS during its peak hour from our calculation are satisfying the requirements. So next, for all the value from the calculation 1 and calculation 2 will be inserted and displayed on the simulation on analogy by my next team presenter, which is Amirul Imran.
Okay, based on the requirement asked from question 1 and 2, so this is the simulation on analogy to meet the requirement from both equation. So based on the question 1, we need to create a S and RS system that able to store maximum to 1200 pallet. So based on the previous calculation on question 1 that has been explained by Jamal, this is the result. These two red and two eyes system. So for this one, rule, and we create a 50 cell with the level of 20, and the maximum height from the ground is 40.3 meter. So based on one rule here, it can fit until 300 pallet. Thus, we have 4 roll. 1, 2, 3, 4. So 300 times 4 roll equal to 1200 pallet. Okay, so based on the calculation value at question 2, we set the value to meet the requirement of the TCS equal to 6.367 minute per cycle, and then the TCD equal to 10.75 minute per cycle. So we run the simulation. So we got a 4 forklift flow the path to take the pallet from the lorry and store to the RS and AS here. While keeping storing, then this pallet will be transferred to the first CNC machine using forklift, and then the pallet will transfer by the conveyor to the CNC2. At the middle of the conveyor, there is inspection for the pallet. So after the finish at the CNC machine 2, and the forklift will store the pallet at the rack here, and finally transfer into the lorry to transfer out. So based on this process, within 1 hour, it can finish around 21 pallet. So I transfer to the next presenter, which is Muhammad Amirul Hafiz.
So now I will continue the presentation by simulate our product in CATIA. Based on the previous simulation in analogic, we got two processing CNC machine, which is CNC1 and CNC2. In CNC1, we are using the roughing process that roughing the product to the shape we have sketched. And then for the CNC2, we are using drilling by making the holes and Z-level process as the end of the process to finishing the product. So before I start the simulation, basically roughing and level parts, the drill bit and mill D10 RC0 are used for, and then for the drilling we are using drill bit drill D5. So now I will start the simulation. Okay, for the simulation, we must click here, manufacturing program, by right click, sorry. So we must click to this start video simulation using toolpath. So basically this is our raw material. Okay, now I will start the simulation. Okay, this is the end of product it will look like. So that's all from us. Thank you.